When you hear the name Gustav Eiffel, you probably instantly picture the Eiffel Tower. It really is the defining structure of his career, isn't it?
Absolutely. It's iconic.
But if that's really all you know about him, you're missing, well, quite a lot. The true scope of his legacy.
Right. We're talking a global network of really innovative infrastructure, pretty shocking political downfall later on, and a whole second career in science.
Which actually fundamentally changed aviation.
That's our mission today, really, to sort of peel back those layers and understand the true genius of the man. His approach married structural engineering to just pure scientific rigor.
And to get to that rigor, we should probably start with his name, his full birth name.
We should. It's quite a mouthful. Alexander Gustav Bonnickhausen dit Eiffel.
Bonnickhausen.
Yeah,
That's the German link.
exactly. It nods to his ancestry. The family came from a German town, Marmagen. The Eiffel part was adopted later, referencing the Eiffel Mountains nearby.
But that wasn't official until much later, right? Like 1880.
Correct. And while that's the heritage side, the foundation for his career, maybe surprisingly, was actually laid by his mother.
Catherine Melanie. She ran a coal business.
A very successful one, coal distribution. So successful, in fact, that she retired on the proceeds back in 1843.
Wow. So that early exposure to, I guess, industrial logistics, commerce, that must have had a big influence.
A profound one. It gave him the capital, sure, but also the intellectual push to go for higher education.
And interestingly, he didn't initially plan to build bridges or towers. He graduated from the École Centrale des Arts et Manufactures in 1855.
Specializing in chemistry.
Chemistry. He ranked 13th in his class, I read.
That's right. And that background, the precise measurement of materials, understanding molecular structures,
That clearly informed his demand for absolute precision in his engineering work years later.
it paid off almost immediately. His first major job, the Bordeaux Overpass, 1861. A 500-meter iron girder bridge over the Garonne River.
That's a huge project for a first job.
Massive. And a real demonstration of, well, technological mastery for the time.
Because the river conditions were difficult.
Very. So to build the necessary masonry piers right there on the riverbed, he adopted some really cutting-edge techniques.
Like compressed air caissons.
Exactly. For anyone listening who doesn't know, caissons are basically these large sealed chambers. You sink them to the riverbeds.
And pump in compressed air.
Right, to keep the water out. That way, workers can excavate and lay the foundation safely down below the water level.
Pioneering stuff for the 1860s.
Definitely. And he wasn't just mastering existing tech, he was pushing the science of materials forward, too.
You mean his work for the 1867 Exposition Universelle, the exhibition hall?
Yeah, collaborating with Henri Trecca, they did some really crucial research on the structural properties of cast iron.
Specifically the modulus of elasticity, right? That sounds technical.
It is, but it's critical. They were basically figuring out mathematically exactly how much an iron structure could safely bend or stretch under load.
Load like wind or trains.
For failing. They were taking the guesswork out of structural safety, making it a science.
So once he set up his own workshops, Eiffel at Sea, around 1866.
The scope just exploded. Immediately global.
Like the church in Peru.
St. Mark's Cathedral in Aircaville. Yeah. All metal, completely prefabricated.
Think about that. Designing and making every single part in France, drilling every hole perfectly.
Then shipping it halfway around the world to be bolted together on site. The logistics alone are staggering.
That required a level of organizational skill few could match back then.
And closer to home, you had things like the Budapest-Nugati railway station in 1877.
That was the one where he didn't hide the structure.
Exactly. Traditionally, you'd have this big iron shed for the trains, but you'd hide it behind a fancy stone facade.
But Eiffel,
He just broke the rule, made the huge metal framework the main architectural feature, celebrating the engineering, not concealing it.
bold. But then came a really high-stakes challenge, didn't it? The Maria Pia Bridge.
Over the Douro River in Portugal, also finished in 1877. A huge test.
Why was it so difficult?
The river there is incredibly deep, it flows really fast, and the riverbed is basically loose gravel.
Which means...
No way to build conventional support piers in the middle of the river, just impossible.
So the solution had to be different.
It necessitated a massive central arch span, 160 meters.
Which was...
A record.
At the time, yes. Longer than any arch span built before.
And his proposal won out.
It did. Not just for the innovative, quite graceful design, but also the price. It was surprisingly low, about 965,000 French francs.
Seems risky to bid low on something so complex.
It would be, except Eiffel had this reputation already for incredibly meticulous calculation. Clients trusted that his low price wasn't a guess. It was based on knowing exactly what materials were needed, down to the last rivet. No waste.
And that expertise, especially dealing with complex forces like wind.
Became highly sought after. So much so that when the Statue of Liberty project hit a major engineering snag,
Eiffel got the call. After the original engineer, Viollet-le-Duc, died. Precisely. Auguste Bartholdi hired Eiffel around 1881. He desperately needed someone who understood wind stresses on large structures.
because the statue is essentially a giant, thin copper sail.
Exactly. So Eiffel basically became the interior architect of Lady Liberty. He designed that famous internal support structure.
The four-legged iron pylon inside.
Right, designed to be strong yet flexible enough to support the copper sheeting and withstand the Atlantic gales.
And just like the Peruvian church, he built it first in Paris.
The whole thing, all 151 feet of it, assembled at his workshop, then carefully dismantled, piece by piece, labeled, packed, and shipped to the U.S.
Incredible quality control. And that experience dealing with wind on that scale must have been perfect preparation.
The perfect apprenticeship for his ultimate challenge, the Eiffel Tower itself, built for the 1889 Exposition Universelle.
Now, we should be clear. The initial concept, the design,
Came from his own engineers, Maurice Coquelin and Émile Nouguet, very important figures.
with architectural input from Stephen Sylvestre.
Correct. But the execution, the sheer engineering audacity overcoming all the challenges, that was pure Eiffel.
And that audacity kicked up a huge storm of public controversy almost immediately.
Oh, absolutely. You had major cultural figures, the writer Guy de Maupassant, the composer Charles Gounod.
Forming the Committee of 300.
Right, specifically to protest its construction. They did not hold back.
What did they say? I remember reading some quotes.
Their petition called it a giddy, ridiculous tower dominating Paris like a gigantic black smokestack, claimed it would crush the city's beauty beneath its barbaric bulk.
Strong words. That must have just strengthened Eiffel's resolve.
Completely. And this is where his background in chemistry, that demand for precision, became absolutely vital on a monumental scale.
To counter the artistic criticism with undeniable engineering perfection.
Exactly. His drawing office produced something like 1,700 general drawings, over 3,600 detailed drawings.
For more than 18,000 unique parts for the tower.
And the accuracy required, well, it was just astonishing for the 1880s.
Rivet holes.
Specified to within 0.1 millimeters. That's 4/1000ths of an inch.
How did they even achieve that back then?
Incredible skill in the foundry and the workshop, absolute mastery, and a strict rule if a part didn't fit perfectly on site.
It went back to the factory. No tweaking or filing allowed during assembly.
None. Everything had to be perfect beforehand.
And the most dramatic construction moment must have been linking those four huge legs angling up from the ground.
March 1888, a critical point. Imagine the geometry involved trying to get those four massive iron legs to meet perfectly hundreds of feet in the air.
How did they manage the alignment?
That was the genius part. They'd strategically built enormous hydraulic jacks into the foundation footing of each main girder.
Ah, so they can make tiny adjustments.
Exactly. Tiny, precise vertical and horizontal nudges to get everything lined up perfectly so the connecting girders slotted right into place.
A masterclass in large-scale practical geometry.
Flawless execution. And when the main structure was finally done, March 31st, 1889, Eiffel himself led a group up.
By foot, right? The lifts weren't working yet.
By foot, all the way to the top platform to hoist a huge French tricolor flag. A 25-gun salute marked the moment.
The absolute peak of his fame. But it was followed almost immediately by a massive crisis.
A huge one. The French Panama Canal scandal.
He got involved in 1887, designing locks.
Yes. Contracted by Ferdinand de Lesseps' company to design and build these enormous canal locks. Most involved an 11-meter change in water level, huge structures.
But the project was already in trouble.
Deep trouble. He'd barely started work when the whole company suspended payments in December 1888 and just collapsed into liquidation.
And that triggered a massive political and financial scandal.
Huge. It implicated lots of powerful people, and Eiffel got dragged right into the middle of it.
He ended up in court.
Charged with misuse of funds. He was fined 20,000 francs and initially even sentenced to 2 years in prison.
Wow. But he appealed.
He did. And crucially, he was acquitted on appeal in 1893. His name was cleared legally.
But the damage was done professionally.
Oh, yes. The public outcry, the political mess, it forced him into a total professional retreat.
Like burning his bridges with the engineering world.
You could say that. He resigned from his own company, the Compagnie des Établissements Eiffel, and basically vowed to stay out of any future manufacturing or construction business.
So, retirement from engineering.
But, and this is the fascinating pivot, it was also the start of his reinvention, his second career, pure science.
Driven by his obsession with data and wind forces.
Exactly. The scandal effectively channeled that lifelong interest into a completely new field for him.
And where better to start experimenting with aerodynamics
Than his own giant tower, the perfect ready-made laboratory.
What did he actually do? Drop things off it?
Sort of. He set up a vertical cable running from the second level down to the ground. Then he dropped various measuring devices attached to different shaped surfaces he wanted to test down this cable.
Ingenious. Using his own monument as the world's tallest wind tunnel, in a way.
Precisely. And he refined this method later with actual wind tunnels he built, one in 1909 on the Champ de Mars, then a bigger one in Auteuil in 1912.
And this research yielded some fundamental discoveries.
Absolutely foundational stuff for early aviation. He established two really critical facts backed by hard data. First, air resistance is very closely related to the square of the airspeed. Double the speed, quadruple the drag.
Okay, that makes sense. And the second?
The second really changed how people thought about wings. He proved that the lift generated by an airfoil, the cross-section shape of a wing,
Comes mainly from a reduction of air pressure above the wing.
not, as many thought, primarily from an increase of pressure pushing up underneath it.
So suction on top is more important than pressure below.
In essence, yes. That slight shift in understanding was huge. It allowed engineers to design much thinner, more efficient wing shapes, directly impacting aircraft design right when flight was taking off, literally.
And the scientific work was recognized.
Globally. He received the Samuel P. Langley Medal for Aerodromics in 1913. It cemented a scientific legacy that you could argue is just as important as his engineering work.
A true two-career man. An incredible life. And it ended, I read, quite peacefully.
Yes, on December 27, 1923, in Paris. Apparently, he was listening to the Andante, the slow movement of Beethoven's Fifth Symphony.
So if we bring this all together, Eiffel's real importance wasn't just building big, impressive things.
No, it was his insistence that hard science, meticulous calculation, rigorous testing had to underpin every decision, from the tiniest rivet detail to the grand sweep of an arch.
He really helped forge a new modern aesthetic, didn't he? Where the beauty comes directly from the structure being dictated by practical, calculated engineering needs.
Exactly. It sort of gave permission for 20th century design to emerge, celebrating function and structure.
Yet despite his global fame, many of his other works, his earlier works, face challenges today.
They do. His very first major project, that Bordeaux railway bridge, the Passerelle Saint-Jean, it was nearly demolished.
Really, his first big success.
Yep. It took decades of campaigning by the public and heritage groups before it was finally protected as a French historical monument in 2010.
That's quite the irony, isn't it? The foundation stone of his career needed this huge fight to save it, while the tower is obviously celebrated constantly.
It really is.
And it leaves us with a pretty powerful question for you, the listener, to think about. Given that even a pivotal early work by someone as famous as Eiffel needed decades of effort to preserve, what critical pieces of our own history, our own infrastructure, maybe less glamorous things, are we overlooking right now, letting them decay or disappear while we only focus on the obvious towering landmarks?